Welcome to the tutorial covering how CADWOLF integrates with the Onshape CAD system. This tutorial is broken up into 3 parts. First, we're going to give you a broad introduction to the Onshape CAD system. Then we're going to talk about how Onshape integrates with our CADWOLF documents systems. And finally, we're going to cover how Onshape integrates with our part tree module. Onshape is a cloud-based CAD modeling system. If you've used something like Pro-E or CATIA or SolidWorks, then Onshape's functionality will be obvious. The main difference is that being cloud-based, your interaction with Onshape is completely contained within the browser. Let's take a look at some of the features of Onshape and talk about how they affect your design in relation to CADWOLF. You're looking at a standard Onshape file, which they call a document. To the left and on the bottom, you can move between the different part studios and assemblies in a file. Right now, we're looking at an assembly containing all of the parts within this file. Clicking through a few of the parts, you can see that each one is designed individually in its own studio. You'll also notice that for each part, there is a feature list, which is the second window from the left. This is one of the key differences between Onshape and other CAD modeling systems, and is very important to CADWOLF. The reason for this is that the design of the part is carried out top to bottom in order here. So each extrusion, each drawing, each thing is done in order in the feature list from top to bottom. While it isn't a necessity when working just with Onshape, the absolute best practice when working with CADWOLF and Onshape is to have one part in each part studio and then combine them in the assembly as you see here. So let's take a look at a very simplified example to show how a CADWOLF document can drive the design of an assembly. The red block in this assembly represents a generic weight. It is connected to a fitting, which then connects to an eye bolt, a rod, another eye bolt, and another fitting, which would theoretically connect it to something at the top there. Now in Onshape, you can move this assembly all around, look at it from any angle that you see fit, and it functions just as any other CAD modeling system would. So let's take a look at the part studio for the rod. As you can see here, it starts off as most would with a sketch, and then that sketch is extruded. However, we have 3 variables at the top of the feature list. Now, a variable is added to the feature list by clicking on the icon in the top menu here. Once it's added, you can simply open it, give it the desired name, and then give it a value to start with. Now, this name that you give it must match the name on the CADWOLF document of the variable sent to it. So once the variable is established, you can go into your sketch, go into your dimensions, and then set the dimension to the desired variable name, preceded by the hashtag. Now you can do simple math within the dimensions here, such as dividing or multiplying by a number, but obviously the best practice is to send the desired variable in that variable and then link it in the dimension there. So now that we've set our dimensions in the sketch, we go into the extrusion, and using that third variable, we set the height of the extrusion. Once that's done, the inner and outer radius of this rod, as well as the length of the extrusion, is dictated by these variables. All we have to do is link up a CADWOLF variable with these variables, and we can drive that model via CADWOLF. Now, going into a more complicated design, such as the fitting, what you can see as we go through the sketches is that this isn't just as simple as sending dimensions and then designing your component. Having to drive the design via those variable dimensions has a great effect on what we call design intent. So you have to think ahead of time about how you're going to design your sketches, your extrusions, and all those things based upon what dimensions you want to send to the model. Also remember that each model is built top to bottom in the feature list. So in order to use a variable, you have to have it declared higher up in the feature list, which is why we simply move all of them to the top of the list once they're declared. Now our weight has a simple height, width, and depth, and we're going to show how we drive that in CADWOLF here. However, before we move on, let's reiterate some of the things that we've covered. The Onshape modeling system has a feature list that builds from top to bottom. The best practice is to declare a variable and place it at the top of the list. That variable must have the same name as the CADWOLF variable you intend to send, and then you simply use that variable in the dimensions to drive the model. You have to be aware that this affects your design intent, however. So now that we've designed a model using variables, let's talk about how we send data to those variables from a CADWOLF document. So this document is available in our examples folder, and here we carry out a very simplified mathematical analysis to design the two fittings and the rod ends depending upon the size of the red weight that they're holding. So to start off with in the document, we have just a couple of screen capture images to give the user a good idea of what we're about to do mathematically. Then we go in, we set a factor of safety, and we actually just set as hard variables the width, the height, and the depth of the red block. Then we calculate the diameter of the eye bolt based upon that weight, and we calculate a few items for the fitting based upon that eye bolt. And then again, based upon the eye bolt as the inner diameter of that strut, we calculate the outer diameter of the strut. So now that we have these simple calculations, let's show how we link them to the Onshape CAD model. We open the Link to CAD window, and what you see, since we've already set these up, is you'll see a list of all of our elements. So the left-hand column shows the Onshape document in question. These are all of our hanging weight document. And the second column there shows the element name that the variables are being sent to. So some are sent to the weight, to the fitting. This is set up by simply opening the drop-down list and selecting the file that we want to send things to. And then you'll be able to select which element you want to send that to, and then simply click the plus button, and an option for that element will be added. So each one of these items was added in that way. You can then click this menu to open up the option to add more equations, and then simply select which equation you want to send. So focusing on the rod element in our hanging weight document, you can see that we've sent two variables. The names of those variables match the items that we used to drive the inner and outer radius for that rod. You can see those variable names here. Notice in this particular example, we didn't actually drive the rod length. A similar process was followed for all of the elements in this document. An entry was added for the element, and then the desired number of variables were simply added to the list that are to be sent to this element. So these elements are sent whenever you hit one of the buttons here for each row to do so, or whenever you save this CADWOLF document. So let's see an example of this. Let's take a quick look again at our hanging weight assembly here. You can see the thickness of the fitting and the rod. It's fairly thick. The weight is large compared to the rod and fitting itself. And what we're going to do is go back into our example document, and we're going to make the height, width, and depth of that weight half of what it currently is. So each one of those is 16 inches now. We're going to change that to 8 inches for each of those, and let the document resolve all of those parameters for each time we change it. Then we're going to save this document, and when we do that, not only is the document, all of the changes saved, but those variables that are linked to Onshape documents are pushed to those documents again. So we take a quick look again at what it looked like before those changes, and then let it update with those changes, and you see that the fitting and the rod are much thinner because the weight is much less. So the process of linking variables in CADWOLF to Onshape models is to solve your equations in CADWOLF, add the desired document and elements in the Link to CAD system, add your desired equations to the list sent to that element, and then those variables are pushed whenever that document is saved. So now let's take a look at the flip side of that. How do we read data in from an Onshape CAD model? So going back to our example document, we once again open the Link to CAD window, and you'll see at the top of that window there is a second option to import a CAD file. Again, this is done in pretty much the same way. You select which document you want to import, you select the element you want to import from, and then in this case you have a third option, which is the part. So obviously once you've selected the element, the parts available will update automatically. Additionally, when you're importing data, you have to give that data a name that you're going to use it as an equation. In the column there for the fitting that we've imported here, we've given it the name fitting. That means you can pull the parameters from that model by simply using the equation name fitting. So in that bottom equation there, you can see that we've pulled the weight by typing fitting.weight. At the time of this recording, you could import the weight, the mass, the volume, and the density, all with the accompanying units. Now that third option when you're importing data was the actual part in the element. You can change the name of this part through this option window here. As you can see, you can click on the scales once this is selected in Onshape, and you'll see the material properties for this part. So to recap, to import data from a CAD model and use it in a CADWOLF equation, you simply open the Link to CAD window, select the desired document, element, and then part. You give that part an equation name, which you use it in further equations using the dot notation for mass, weight, volume, or density. Okay, so let's briefly go over how we use these Onshape models in part trees. Now this is covered in a lot more detail in our part trees tutorial, but it's a good thing to go over here just so you can see how those documents relate to the part tree. So over in Onshape, we have a fairly complicated truss system with the same sort of struts and fittings that we saw in the previous simplified hanging weight model. So for each entry in our part tree, we have a menu with the option to link to CAD, and selecting this option will open the same window that you saw earlier, where you can simply select the document that you desire, the element, and the part. Once this is done, you'll see the representing icon in the same row. There is an option to open each CAD file in a separate window, as well as an option to look at the CAD properties. As you can see, these are the same properties that you saw in the previous menu for the part. In addition to this, you can also select the option to update these properties, which will simply ping Onshape again for the current values of each of these masses and inertias and all the items you just saw. Now, linking these items here to a CAD model is totally separate from linking them in documents. And what it does is not only provide an icon to show what each document represents, but as you can see here, we select a certain property that we want to import from each CAD file to be displayed. And CADWOLF goes in and displays that value for each part or system, whatever element you chose to be linked to here. You can look in the part tree demo or tutorial and see exactly how useful this is. It is essentially real-time feedback for the status of each model. CADWOLF also provides a tool to let you see which CADWOLF documents push variables to a given Onshape model. If you look at the URL for any Onshape model, you'll see after the /documents entry a unique number. This precedes the /w. You can copy this string and then come over to CADWOLF in our connections, CAD connections module. Simply paste this ID string and hit return, and you'll get an entry for each element that is connected from a CADWOLF document. Here we have several elements connected to the hanging weight document. Well, that's it for the tutorial on linking CADWOLF to Onshape. If you have any more questions, check out our documentation and make sure to follow us on Facebook and Twitter.